So what we're going to do now is use one of our new identities to prove a cofunction identity that we've already been using. Example 4 at the top of page 379 says we're going to use a cofunction identity to prove one of our sum and differences identities. So our goal right now is to prove cosine pi halves minus x is the same thing as sine x. And we recognize these as one of the cofunction identities, cosine. And 90 minus x is the same thing as x. And it works both ways. We know that sine of pi halves minus x is equal to cosine x. So we're going to use this difference identity, cosine u minus v, and straight out of that box, the ones that we're memorizing, we know the cosine of u minus v, replacing u and v with pi halves and x, we're going to input it into our formula. That's cosine u cosine v, in this case cosine pi halves, times cosine x, sine of pi halves, sine of x, sine of uv. Cosine of pi halves, of course, is 0. 0 times cosine x, that simply disappears. Sine of pi halves is 1 times sine x, and we get our final answer. You guys verify problem number 73. It's very similar to this. We're verifying a sine, one of the functions. Come back and check your answer. We're verifying the sum formula sine of u plus v, and in this case we've replaced u with pi halves, v with x, and we're going to show that that is equal to cosine of x, the cofunction identity. So we're going to use the sum formula, sine u plus v, sine of u is pi halves, v is x, so it's sine pi halves cosine x, plus cosine pi halves sine of x. When we simplify that, sine of pi halves is 1, times cosine of x, cosine of pi halves is 0, so this whole term disappears, and we're left with cosine x. Let's take a look at example 5. Example 5 says we're going to derive one of our new formulas. It's a reduction formula. We're going to simplify cosine of theta minus 3 pi halves. And we'll just start with that one. It says using the formula for the cosine u minus v. We have this cosine of theta times the cosine of 3 pi halves plus sine of theta sine of 3 pi halves. We're just using our difference formula. Cosine of theta, cosine of 3 pi halves, we get a 0 here. 0 times cosine of theta. And on the other side we get sine of theta. Sine of 3 pi halves is negative 1. And we end up with the negative sine of theta. So we're going to use the sum formula for tangent u plus v. And we have simplifying tangent theta plus 3 pi. So we're going to do that, plug it into our formula. Looks like this, tangent u plus tangent v over 1 minus tangent u times tangent v. So you can see I've plugged those values in. On the top we have tangent of theta plus tangent of 3 pi, which is simply 0. And we have 1 minus tangent of theta and tangent of 3 pi, which is 0 again. And you can see that that simplifies to tangent theta. So go ahead and try exercise 77. For this top example, it says note the period of tangent theta is pi, so the period of tangent theta plus 3 pi is the same as the period of tangent theta. Theta plus 3 pi, same as the period for tangent of theta. So check 77, come back and see if we match up. Alright, this looks long and scary, but I think we can get through it. I'm going to be referring to page 377, looking at my two my sum and my difference formulas. So I'm going to go ahead and simplify this first part, sine x plus y. We know sine x plus y is sine x cosine y plus cosine x sine y. And the simple second part is what I meant, sine x minus y is sine x cosine y minus cosine x sine y. Then we look for like terms. I can see a cosine x sine y and a minus cosine x sine y. See those guys cancel, and I can see sine x cosine y plus sine x cosine y, giving us what we set out to prove. The whole thing is equal to 2 sine x cosine y. And that's problem 77. That was example 5. We're going to go through example 6. Hopefully it fits here. So we've got some new excitement in example 6, page 380. It says we're going to solve this now. It's like prove the identity, and then we got to solve the trig identity equations, which was far more satisfying and fun. So we're going to simplify this sum. This is sine x cosine pi fourths. We're going to add to that cosine x sine of pi fourths. And keep in mind we are on the interval 0 to 2 pi. And we're going to add to that the second part. We'll put it right underneath, which is sine x cosine pi fourths. And minus, because we have a difference formula here, cosine x sine pi fourths. And we can see, and that's all supposed to equal -1. So I'm going to line up my like terms, cosine x sine pi fourths minus cosine x sine pi fourths. One's positive, one's negative. I can see that those are going to cancel. And I end up with 2 sine x cosine of pi fourths equal to -1. So we look at this and we see we can evaluate this. Cosine of pi over 4 is square root of 2 over 2. And we have a 2 out front and a sine x in the middle. If we simplify to that -1, we're going to get -1 divided by the square root of 2, sine of x. And we can see if we get the radical out of the denominator, we get the sine of x is equal to negative square root of 2 over 2. And we should recognize that negative x should give us 5 pi over 4 and x 7 pi over 4. Remember, we're on the interval from 0 to 2 pi. You guys try number 81 and come back and check your answer. 81, very similar to the last one we did. So sine x cosine pi thirds, we're going to simplify. This whole thing happens here. This whole thing is happening here. We're looking for common terms. Positive cosine x sine pi thirds is going to cancel out there, and we end up with 2 sine x, and cosine of pi over 3, cosine of pi over 3 is 1/2. So we're going to plug that in, times 1/2, and we want to see what value of x gives that whole equation equal to 1. So we're going to go ahead and do this. 2 and 1/2 cancel. We get the sine, we get the sine of x equaling 1 for problem 77. And we know that the sine of x is equal to 1. from 0 to 2 pi at pi halves.